yesterday, and we're on page 13.
You want to take that third page, class, or this will, okay.
Okay, so page 13, we're going to skip number 4 and we're going to go down to number 5. Okay, so number 5 says if velocity of a particle is v of t, find a of t and find acceleration at g equals pi. So this is the particle, position, velocity, acceleration. Typically, we would start at position, then derivative to get to velocity, and then derivative to get to acceleration. But here, it's already giving us information at the velocity level. So to get to acceleration, we should do one derivative down. But look at how our velocity is set up. What would we need to involve here to find the derivative? Product rule. Okay, so f prime g plus f g prime. Let's just take a pause here just to go back. So I know we're skipping number 4 here, but if we can spend a minute just to recall our 6 derivative rules. So let's see if we can just jot them down real quick. Okay, we'll do this at the end of class too, so that we can get that practice in. Okay, so derivative of sine. So we can put the sine, tangent, and secant in the first column. Second column, we'll do all the functions that start with c, because there's a nice property with all those functions that start with c. We'll put them in alphabetical order. Okay, so sine and cosine really just involving each other. So sine is cosine. Cosine is negative sine. And that's the nice thing about all these c functions. If you put it in this order, is that you can line up all the functions that will produce a negative derivative. Right, tangent just involves the one below it. So tangent is just going to be secant squared u times u prime. And if you can figure out tangent, then you can follow the same pattern with cotangent. Cotangent, we'll just use the one right below it. And then secant is going to involve itself and the one above it. Okay, so secant u is secant u tangent u times u prime. And then cosecant just uses the one above it, follows the same pattern, just with a negative. Okay, just want to review those rules, and then at the end of class, I want us to see if we can do it from scratch and practice writing down all the rules. All right, so number 5, we said that we're going to do product rules, so let's set it up using product rule. Okay, so f prime g plus f g prime. What's sine 2t's derivative? Times 2. Yep. So cosine u times u prime. Good. All right. Our g function will just remain at tangent of t. Our f function will remain at sine of 2t. Now ready for tangents derivative. Tangents is just secant squared e times 1, but that times 1 we can just let it drop. It's not going to affect anything. Not much we can clean up. I'm just going to push them a little closer together, move that 2 out in front. Okay, so part B. Asking to find the acceleration at t equals pi. So what can we do there? Place t with pi, right? So as I do that, I think this is also another place where you want to get that exponent in a more visually helpful position. So we definitely want to rewrite it outside a set of brackets if we're dealing with a derivative. But I think also if you're trying to evaluate a function, having that exponent outside makes it less confusing. So I'm going to first rewrite it as squared, and then I'll put the pi in. And so therefore, that helps remind me, I'm going to figure out what secant of pi is, get that ratio, and then I'm going to square it. Because sometimes looking at that exponent too, it kind of throws off, what you're really trying to do there. Okay, we're not squaring secant, we're not squaring the pi. Okay, we're finding that ratio and then squaring it. Okay, so every t value gets replaced with pi, and now these are all just unit circle values. Okay, what's cosine of 2 pi? Same as cosine of 0. What's cosine of 0? 1. Okay. Okay, what's tangent of pi? Yeah, tangent of pi is 0 as well. Okay, and then sine of 2 pi is going to be 0. Okay, and then secant of pi is related to cosine, right? What's cosine of pi? -1, right? And if I flip -1, I still get -1, and -1 squared is going to be +1. Now it's going to be a moot point because everything is 0, so it gets zeroed out. But I want us to get that practice with unit circle values.
Why is the square with?
It just helps us recognize what that squared is doing. It's squaring the ratio. So we're not doing any changes to it. I think it's just visually more helpful understanding how that squared is impacting our answer. Okay, number 6. Y equals tangent cubed of x. We want to find the tangent line equation at that x value. So anytime we're dealing with tangent line equation, we know we got to find the order pair, and then we need to find the derivative so that we can find the slope and then point slope form. So let's first start off. How should we? What should we do before we start anything? Yeah, get that 3 to show outside a set of brackets, right? Just makes it easier for interpreting what's happening. Now, is that exponent going to affect everything that we see there? Good, just a tangent, right? The 2 is outside that. It's not the 3. That exponent doesn't see the 2. It only sees the tangent. Okay, so this is where I would start. I'll rewrite it as 2 bracket tangent x cubed. It's going to be helpful in terms of evaluating. It's also going to be helpful when we find the derivative. So let's find the order pair first, right? So I can insert pi over 4 in for x. That can get my y value, and I can get that out of the way. So 2 tangents pi over 4 cubed. And what's tangent of pi over 4? Just 1. Okay. And then we do 1 cubed, which is 1 times 2, which is 2. Right. So make sure that you're following order of operations, that you're not doing 2 times 1 and then making it 2 cubed, which is 8. Right. So here, exponents take precedence. We resolve the exponent and then we come back and do the multiplication. Good. We have our order pair. next we need to find the slope, but we need to get to the derivative first. To get to the derivative, we're gonna need to use what? Look at how this is set up. I gotta go through chain rule, right? So chain rule, outside, inside, seeing that bracket helps us distinguish between the outside and inside, and also helps us see the need for chain rule. Okay, so our outside portion is that 2 bracket cube. Our inside portion is that tangent x. And then we just take turns with each derivative. Okay, so 2 bracket cube becomes fixed bracket squared. Yep. So, and we insert that space with tangent. Okay, and after we take care of that derivative, now we're ready for inside's derivative. Tangent just becomes secant squared. Right. So make sure that you don't insert that secant squared in that bracket. The inside derivative, it's going to be in a separate space. Okay. So we have our y prime. Now we can find the slope. Plug in our x value. And again, before I do that, I am rewriting that secant as bracket secant x squared. So I'm reminding myself, I'm going to find the ratio before I square it. Okay, so replace every x with pi. Okay, so again, tangent of pi over 4 is 1. Okay, so that's easy. Secant of pi over 4, maybe this is not as recognizable to you, but what's related to secant? Cosine, right? And cosine of pi over 4 is root 2 over 2. So therefore, secant is going to be what? Yeah, 2 over root 2. So you can either rationalize it or you can leave it as 2 over root 2. Either way, it'll clean up nicely later on. So let's say I use root 2 over root 2. So the 1 is going to get squared, which is still 1. The 2 over root 2 gets squared, which is 4 over 2, which is 2. And 6 times 2 is 12. So there's my slope. So I have my ordered pair. I have my slope. Now I can put into point slope form. Okay. Hopefully a lot of this feels familiar. You do need to review your unit circle, but calculus-wise, I think the biggest issue I see is not rewriting it. Okay, if you don't rewrite it, I'm not going to take points off, but typically that leads to mistakes with chain rule. Okay, so if you rewrite it, seeing that bracket with outside inside is a lot more helpful, a lot more familiar in terms of chain rule that we're used to doing. Okay, we're going to work through page 15. But we'll skip number 2. Okay, so we'll do 1, 3, 4, 5, and 6. Largely going to let you do this, but I do want to start us off on the right foot, make sure that we're on the right track, and then have you guys try it and we'll compare our answers. Okay, so look at number 1. We're asked to find the derivative. Page 15. 4x cubed, tangent 4x cubed. What's the rule that we have to apply here? Product rule. Good. So I want us to make sure that we can see product rule. Then we know, okay, I got to spell out each of the parts of product rule, and then within each part, I can take the derivative of 4x cubed and the derivative of tangent 4x cubed. All right, let's try that. See if you can Make your way down to the derivative. F prime g plus fg prime. Make sure we remember when we do tangent, the rule is secant squared u times u prime. We gotta have that u in place as well as the u prime. They both are going to show up in your derivative. Questions? Okay, we'll skip 2 and go to 3. Yeah, you could take out a GCF if you want, but I'm not gonna be picky about that on the quiz. Number 3, look at number 3, look at how number 3 is set up. What's the big picture here? We have to make sure we involve what? Implicit, yeah. Anytime you see y not by itself, you know you gotta collect your dy dx. There's only one y though, so only one dy dx will pop up, which will make it easier to get that by itself. Okay, what else? Yeah, we need to, the problems aren't gonna announce product rule themselves. Gotta make sure you can look for it and that you can recognize it, right? 3x and sine 5x are separate terms. You gotta go through product rule there. Okay, by that. Remember, cotangent's derivative is negative cosecant squared u times u prime. Okay, once you find the derivative, there's only one thing left to do. It's just to divide that negative cosecant squared y. We don't even have to rearrange anything because the dy dx is already by itself pretty much, and there's only one dy dx. So in this problem, there's no need to select the dy dx's or factor them out. It's already almost near the end. Any questions with 3? Okay, look at number 4. Number 4, we're asked to find the first and the second derivative. So 4/3 tan of 4 theta, and jump directly into our tangent rule, right? Secant squared u times u prime. So 4/3 stays. Tangent u becomes secant squared of u, so the 4 theta is going to show up, but then we're also going to need a times 4. Okay. What would you do to get this ready for second derivative? Yeah, put the square outside of brackets, and also we can merge like, yeah, the 4 and 4/3 together, make it 16 thirds, right? So anytime you see that square, okay, you gotta try to make it a habit to try to rewrite it. If you don't rewrite it, it just makes it, you're gonna make yourself vulnerable to make mistakes. It's just harder to see the necessary chain rule portions if you don't rewrite it. So. But now this becomes very clear for our next derivative. There's an outside, there's an inside portion, chain rule. We're going to take turns with each derivative. Okay, so try that. See if you can work your way down to your second derivative from here. So we go through power rule, 16 thirds times 2 bracket to the first power. And then multiply by the secant derivative. Secant u becomes secant u tangent u times u prime. So here's my outsized derivative. My insized derivative. Okay, we can do a little bit of cleanup, bring that 4 out front with a 3203. We can push 2 secants together, make a secant squared. Okay, any questions with 4? Okay, try number 5. Number 5, similar to the problem that we did on the previous page, find the equation with tangent lines. So use your x value to get your y value. To into the function to get your y value, find the derivative. Then you can use that and the x value to find your slope, and then point slope form. Okay, give you guys a minute to start number 5, and I'll walk through the problem with you. Does anybody still need number 4? All right, to find the order pair, we can evaluate cosecant at 2 pi over 3, plug 2 pi over 3 in for cosecant. If you're unfamiliar with cosecant, then just think about something that's more familiar. Think in terms of sine and figure out the ratio for sine, right? Sine of 2 pi over 3 is going to be in that pi over 3 family. We know sine is going to be positive, and it's going to be root 3 over 2. And if sine is root 3 over 2, we know cosecant will keep the same positive, flip it, right? Cosecant and sine are reciprocals. So my y value is just 2 over root 3. You can leave that radical in the denominator, or you can rationalize it. Either way is fine. Next up, we can find the derivative. Negative cosecant u cotangent u times u prime. Replace all the x's with 2 pi over 3. Get it down to a number, and that will be our slope. Okay, we already know what cosecant of 2 pi over 3 is. Cotangent of 2 pi over 3. We know cotangent is the reciprocal of tangent. The tangent is y over x, so cotangent is x over y. We're still talking about this pi over 3 family, so we can just divide x over y, so 1 over root 3. But we know in the second quadrant, cotangent is negative, so it'll be negative 1 over root 3. So I have negative 2 over root 3 times negative 1 over root 3. And that comes out clean to be just 2/3. Cosecant is normally positive, but there's a negative that's attached in front, so that's why it shows up as negative 2 over root 3. So we have our order pair, we have our slope. Now point slope form. Okay, any questions with 5? Okay, last one here, number 6. This is a particle motion problem. You're starting with position, and you're asked to find all the way down to acceleration and to evaluate the acceleration at 3 pi over 4. So we have to make our way down 2 derivatives. So find the first derivative, get down to your velocity, and then we can work from there to our acceleration. Okay, try that, try number 6. Right, cotangent's derivative is negative cosecant squared u times u prime. I can pull that negative 2 out in front, make it negative 2. But before we move on to acceleration, we should do what? Get that exponent in a more helpful location. So let's put it outside a set of brackets, but it's only going to be around the cosecant. It won't affect the negative 2 in front. So now this becomes more clear. Oh, if I want to find the derivative, I got to go through chain rule, right? I see the bracket. I got to do outside, inside. Outside is that negative 2 bracket square. The inside is that cosecant of 2t. Okay, outside's derivative first, negative 4 bracket to the first power. And the cosecant becomes cosecant, negative cosecant u, cotangent u times u prime. Okay, if I put all the coefficients together, I can put the negative 4, the negative 1, and the 2 all together out in front. I can make that cosecant 2t quantity squared. And once I have my acceleration cleaned up, I can move towards evaluating my acceleration at 3 power of 4. All right, cosecant may seem unfamiliar, but we know sine is familiar. So what's sine of 3 power of 2? Close. Right, the order pair at 3 power 2 is 0, -1, right? So just the y value, -1 will be sine. So if sine of 3 power 2 is -1, then if I flip it, I still get what? Still -1, right? So that's -1 here, -1 here. Cotangent is what? Yeah, because we know tangent is y over x. So cotangent is x over y. 0 over -1 is still 0. So it's going to end up being 0, right? 8 times -1 times -1 times 0. Acceleration is 0. Okay, any questions?
So cotangent of 2t just equals 1.
Cotangent of 2t. Okay, sorry. So what I did was I replaced all the t's with 3 power 4. 3 power 4 times 2 is 6 power 4, which reduces to be 3 power 2. All this 3 power 2. And then that 2 I pulled out in front to be part of that 8. And then cotangent of 3 power 2 is, we know it's talking about this angle here. Cotangent is x over y, so 0 over -1 is 0.
No, okay, thank you.
Okay, one more thing I want us to do is I want us to practice writing out these 6 derivative rules, but right now don't write anything. Just look at this for a minute. And then I'm going to ask you to get out a blank sheet of paper and write down these 6 rules. Okay. All right, go ahead and try that. Organize it in 2 columns. I think that's the best way to see all the connections between the trig functions. All right, check your derivative rule. If you make a mistake, it's okay. We'll still have some time to, after break, Monday, we'll run through this a couple more times and say your, morning or right before your quiz, we'll run through this again. The last thing I want to make sure that we're good with is unit circle values. Okay, so we went through unit circle in your packets, but if you feel like you're shaky with unit circle, we need to make sure that you're comfortable with it. Okay, so I have a couple of half sheets there. You can make sure you can grab one. I put flag unit circle on both sides, so if you want, just get that additional practice. Because on the quiz, you need to recall those values, right? Like tangent of pi over 4, cotangent of 3 pi over 4, right? To be able to get those values. I'll give you a black unit circle on the quiz if you like, but we need to be able to feel comfortable with those. Okay. All right, that's all I have. Hope I get your phones.
Yeah. So.